Guys, today we are back solving another daily question. Let me just set up my so today's question is called Stone Game. Let's just Abhi khulna. Okay. Okay, so what's the question? Alice and Bob play a game with a pile of stone. Again Alice and Bob, okay. So yesterday's question was also game theory. That what was that? Selecting an array element, first or last element you have to select. Here's yesterday's question. Today is also some sort of game theory. Okay, let's see. Alice and Bob play a game with pile of stones. There are even number of piles arranged in a row, and each pile has a positive integer number of stones. Piles of 5. Okay, there are an even number of piles arranged in a row. Okay, and each pile has a positive integer number of stones piles. Okay. The objective of the game is to end with the most stones. Total number of stones across all piles is odd. So there are no tiles. Total number of stones are odd, but each pile okay, has a positive number of stones and there are even number of piles. But total number is odd. Okay. So three things. Right? So first thing is even number of piles. So let's say even number of piles. Okay. Second thing is each pile, so pile of I is greater than 0 and the last thing is summation of all pile of I is odd. This is odd. Okay. Three things we know till now. Alice and Bob take turns with Alice starting first. Each turn a player takes the entire pile of stones either from beginning or end of the row. This continues till there are no more piles left, at which point the person with the most stones wins. The return true if Alice wins or false if Bob wins. Isn't this similar to yesterday's question? This is similar to yesterday's question, right? I mean, yesterday's question was also this only. Can take either the first or the last. First row becomes 3, 4, 5, and now they can take 3 or 5. Yeah, this is essentially yesterday's question. But the only difference is today the sum of all the elements is odd, so you can never have that equal condition. So yesterday we had a condition saying that if player 1 scores a equal score as player 2, then player 1 is the winner in that case. That was one condition given to us, but today that won't be possible itself, is the point. Piles dot length is even. I don't see how this matters. I don't think that should matter to us. So I mean, right off the bat, I'm thinking a very DP solution, which is to say that I will create a DP array of I comma j, where what does this state represent? This state represents what is the score. So if I am player starting right now and my array, I have array I to j available, what is the score current player can get from array of I to j. So yesterday we had a thing that the length of the array was only up till 20. So we did a brute force recursive solution, but today we can optimize that into a more DP solution, which is to say that this is our DP state. So let's actually, you know what, let's write our let's iteratively go and we will write our solution, right? So the first step is, let's just get our size of the array once. Okay. Now what do we want? We want to say that Alice is the first guy starting, right? So we want to say that return helper of piles comma 0 and n minus 1. So the entire array 0 to n minus 1, we want to see whether this score or the score difference rather. So let's call this score difference. Okay, I'll tell you why, is greater than 0. Okay, and now we'll say int score difference vector of int ampersand, let's just call it array, int l int r. Now what does this function represent? This function represents what is the score difference between current player and other player, what is the best score difference, let's say what's the best score difference between current player and other player possible from this state. Okay, so now if L is equivalent to R, simply return array of L, right? That is a simple case. Otherwise, int, if I take from the left hand side, if left chosen is equal to, so what will be my score first of all? So I have chosen the left, so my score will be array of L. Now I want to calculate the difference between my score and the next person's score. So what is the next person's score? Next person's score is going to be nothing but score difference of array L plus 1 and R, right? So now because I took the Lth element, they have L plus 1 to R to choose from, and now it'll be their chance. So whoever is calling this function, it's their chance basically, right? So that's why I'm subtracting it from my score. So I know that this is the this is the difference I will get if I choose left. And similarly, I can create a variable which will be right chosen, and that will be array of R. And now my range for the opponent is L to R minus 1. And now simply I will go ahead and say return maximum out of left chosen and right chosen. Okay, this should work. Of course, I mean, it will not work. Yeah, see, so that works. But of course, because it is up till 500, if I submit this, we are going to get a TLE. So we're going to optimize this a bit. So let's do the very obvious simple optimization first. Let's n is only up till 500, right? So that's not a lot. So if you see 500, if I go ahead and create a 2D array, so 500 into 500 is 25 with 4 zeros, that's 250,000. Or rather, you can also call it like 2.5 1e 1 to 5, right? So 1e5, 2.5 into 1e5. So that's pretty decent, I guess. So what I can do is I can go ahead and say int array, or rather let's call it dp of 500 cross 500. And once that is done, I will, every time I call this function, I will go ahead and say fill dp. I have actually forgotten how you assign variables in C++. Gosh, I have actually forgotten how you assign variables. I think this is how you do it. I'm not really sure though. We'll figure out. So if dp of I, or rather L comma R, is not equivalent to -1, return dp of L to R. So we have already calculated it, we'll just return it. Otherwise, we will assign it that value and we will then return it. Okay, so this is the wrong way of doing it. Array type. Oh, bro, I've actually forgotten how fill works. Array in C++. Yeah, see. Array, but this is for a array. This right. Fill with an array. Let's say 2D array, right? I have bloody forgotten how you assign. There is a certain way of doing this. Okay, so because you're passing 2 pointers. I'm not sure if this will work. Okay, but okay, let's try. Let's see. Alright, that doesn't work, right? Bro, I've genuinely forgotten how you do this. Oh, you can use this, okay, so let's do that. So let's do dp is equivalent to -1. Not even sure if that will work. Yeah, this also doesn't work. Let's try initializing it here itself. Yeah, this is also wrong. There's something wrong with this initialization. I've forgotten how you initialize a value. Okay, let's do one thing. Let's go to ChatGPT and ask it. let's see what it says. Yes, this is exactly what I wanted. Oh my gosh, she, yeah, bro. That's what. Like, I knew that it's something along the lines of this. You have to pass the pointer. So what you do is you pass the first pointer. So the first pointer in this DP array is nothing but 0 of 0, and then the last pointer is nothing but 499, 499, and finally you say fill it with -1. This should work. I'm hoping. Oh wow, this also failed. What? Oh, the pointers go like ampersand. Okay, very interesting. Yeah, I mean, I feel like this is the easier way of doing it, which is to say memset dp set, wow, set all values to -1, where size of dp, it's all, yeah, this is, I feel, the easiest way of doing it. Yeah, this is what I used to do also. I've bloody forgotten everything now, bro. Right, so we see that, okay, there's passes, but of course our time is extremely slow because we are doing a top-down DP, right? So we are breaking a larger problem, which is 0 to n-1, into smaller sub-problems, and we are memoizing each sub-problem. Instead, let's do a much simpler thing, which is to say we'll do a bottom-up approach, right? So we'll say, let's create a vector of int dp, and we will size it at n, and n cross n. So that's our DP array. And now instead of returning this, what we will say is still the DP state still remains the same, right? So our DP state is still I to j represents score difference current player can get from array of I to j, right? So this is still our state. So in that case, what is our base case? Our base case is, of course, if we are at the last element, which is I is equal 0 to n, in which case we will say dp of I comma I is equivalent to piles of I, right? Now for int size is equal to 2 onwards, size less than or equal to n, size plus plus. For int l is equal to 0, l less than n, l plus plus. Int r is equal to l plus size minus 1, right? So l and size, I'm calculating windows of size. So for every window I will calculate the answer. Now I calculated the right pointer. If r is greater than or equal to n, then I know that this window is no longer valid, so I can simply break. Otherwise, int left choice is equivalent to piles of L plus, I mean, of course, the same logic as here. So piles of left plus dp of L plus 1 and R, and int right choice is equivalent to piles of R plus dp of L and R minus 1. And lastly, simply you do dp of L comma R is equivalent to maximum out of left choice and right choice. And finally what you will say is whether dp of 0 to n minus 1 is greater than 0 or not. Okay, so that should be our what? Oh, okay, because that function, right, now it should work. I removed that function now, right? Yeah, so that works. We should get a pretty good optimization in time, I believe. So if you look at the submissions, okay, that's not a lot actually. That's not a lot, to be honest. That's whatever. Okay, now here's what you need to notice, right? So if you think of the DP states, what we are taking, right? Oh wow, sorry, forgot about this. Okay, so if we actually think about the DP states, that, so let's consider this thing of an array of size 5 cross 5, right? So oh wow, okay, 1 2 3 4 and 5, and similarly we'll go ahead and say command C, control V, we'll rotate the entire thing a bit and we'll paste it here. Okay, now so 0, oh, let's actually take a different color for the array indices. 3 4 0 1 2 3 4. what was our base case? So let's consider an example itself. Okay, 3723. So 3723, and because we have taken 5 elements, let's consider one more element, 5. Our base case is, so if we are calculating I to I, our answer will be this, right? This is our base case. Now when I'm calculating answer for 0 to 1, what is my answer? 0 to 1. L of 0 to 1 is, if I take the element at 0, which is 3 basically, 3 minus, yeah, if I have taken 0 to 1, I have taken 0, what is left? 1 to 1 is left, which means the other person will get 7. This, or else I will take the 7, which is the second element, and the other person will get to take 3, and I will take the max of both of these. So I will take basically from here, I will take the max of this or this, right? So the max of this or this is nothing but 7, right? I mean, of course, not the max of this or this. Basically, what I mean to say is the max depends on this and this, right? So the max is either this 3 minus 7 or 7 minus 3. So of course that answer will be 4 in this case. Similarly here, what you will get is 7 and 2. So from 1 to 2, if 1 to 2 is your subarray, then the maximum you can get is 5, here 1, here 2, right? So you see that this diagonal, we are filling it diagonally, right? Because we are going size wise. So 0 to 1 is one window, then 1 to 2, then 2 to 3, then 3 to 4. Next window we will take is 0 to 2. Now when 0 to 2 comes, so what is our answer? For 0 to 2, our answer is either we take this 3 and then we give the other person 1 to 2. So if we take 3 and we give the other person 1 to 2, 1 to 2 pe he can earn 5, or else we take the 2 and we give the other person 0 to 2. So 0 to 2 pe, sorry, 0 to 1. 0 to 1 pe the other person can earn 4. So minus 2, both are minus 2. So this answer is minus 2 still. So my point being that each diagonal depends on just the previous diagonal and nothing else, right? It just depends on the previous diagonal. What I mean to say is, I can, instead of having a 2D array or 2D DP table, I can simply have a 1D DP table. Okay, and now what will happen is, I will not make much changes to this. I will simply state that so of course initially the diagonal is equivalent to the array. Okay, now when I will do this, what I will say is, now if you closely look at this, this is my diagonal, right? So 0, 1, 2, 3, 4. I'm saying array indices, right? And the indices of these are 0, 1, 2, 3. So this 0 depends on previous 0 and 1. This 1 depends on previous 1 and 2. This 2 depends on previous 2 and 3. So so the DP of L, right, depends on, one is L, depends on, first is L plus 1 and next is L. Okay, so I will simply just do this. Oh wait, so I should just get rid of this also. Now this should work, I guess. Yeah, and I think we should have a pretty good space optimization here. So yeah, that kind of worked, and you see that, okay, we have a time optimization as well, and we have a space optimization as well. So that's a pretty good solution, I believe. So yeah, that's pretty much it for today. See you tomorrow. Bye bye.